Hi, in this video I will continue to explain Ethereum Virtual Machine. We will see how Ethereum Virtual Machine works, message call transactions, and gas and fees. So how does EVM work? To be able to understand it, we will have a diagram and we will try to describe the elements in this diagram. So we have an Ethereum Virtual Machine, right? And in this machine, we have a machine state, which is a dynamic representation of the current state of the Ethereum Virtual Machine, including the state of the blockchain, the smart contracts and their storage, the state of the stack, the state of the program counter, and the state of the memory. So let us see them one by one. Program counter is a pointer that tracks the location of the next instruction to be executed in a smart contract. Gas available is sent with the transaction. If the gas spent exceeds this value, the transaction is terminated. The stack is responsible for executing smart contracts and it's designed to be deterministic. Memory is used to store data during the execution of a smart contract. So we also have virtual RAM. It's the memory space where the code of a smart contract is stored. Storage is where data associated with smart contracts stored. So in this regard, if you don't have a technical background of some computer science courses, these things might seem so complicated. But what we need to understand is EVM is the runtime environment for smart contracts on the BNB Smart Chain blockchain. All right? It's responsible for executing the code of smart contracts and ensuring that all transactions are properly processed and recorded on the blockchain. So the EVM operates on a virtual machine, which is software-based implementation of a physical computer. It's designed to provide a secure and isolated environment for executing smart contracts since it executes the contract code in a sandboxed environment. So smart contracts are written in a high-level programming language such as Solidity, as I mentioned before, and then compiled into EVM bytecode, which can be executed by the Ethereum Virtual Machine. Alright? When a smart contract is executed, the EVM processes the contract's bytecode, which enables to execute its instructions and updating the state of the blockchain. So in summary, the EVM is the backbone of the BNB chain blockchain, and it provides a secure and isolated environment for executing smart contracts and processing transactions. Alright? You can also go to this source where we adopted this diagram and see about Ethereum Virtual Machine. Message call transactions. A message call, also called a contract call, allows smart contracts to interact with each other on BNB Smart Chain. It's a type of transaction that triggers the execution of code associated with a specific contract address and enables the creation of complex decentralized applications. A message call transaction causes the bytecode of a specified address to execute step by step on the Ethereum Virtual Machine. The EVM uses a stack for data exchange between memory and storage during operations. I will have a diagram in a minute and you'll understand it visually as well. Transactions may involve sending message calls to other contracts. When a smart contract needs to write or read data from the blockchain, it is processed through this stack storage. If the gas consumed exceeds the available gas value, the process is terminated to maintain the integrity of the blockchain. So here we have the diagram, all of those explanations. So in the Ethereum Virtual Machine, the stack is used in conjunction with message calls to pass parameters between contracts and to store intermediate results during contract execution. A message call is initiated when a contract calls another contract's function or when a contract executes its own code. The message call pushes a series of parameters onto the stack, which the called contract can then access and use as input to its own code. The called contract can also modify the stack, adding or removing values as needed. So in this regard, the stack is a crucial part of the message call mechanism in the Ethereum Virtual Machine because it provides a way for contracts to interact with one another and to modify the state of the blockchain. The stack operates on a last in, first out principle. So if you are familiar with data structures, you might also be familiar with a LIFO, last in, first out principle. But if you don't know about it, it's also okay. You can check it out if you want to learn it in detail. The stack operates this principle, which means that the last item added to the stack is the first item to be removed. All right. So to wrap up, the stack and message calls are closely related in the EVM, as stack is used to pass parameters between contracts and to store intermediate results during the contract execution. And message calls are a mechanism for initiating contract execution for allowing contracts to interact with one another. All right. So let us also see gas and fees in this regard. Bytecode is the code executed by the Ethereum Virtual Machine, and it's made up of series of OpCodes. Okay. So each OpCode opcode has an associated gas cost, which is consumed during the execution of the corresponding operation. The concept of gas is used to promote the efficient use of its resources by charging for the execution of certain transactions. This serves as an incentive for users to carefully consider the resource usage, promoting the overall efficiency and scalability of the EVM. So gas is consumed during specific actions such as retrieving data from storage, writing data to storage, and sending transactions to other addresses. So in this regard, in EVM, operations, stack, storage, and gas are all related components that work together to execute smart contracts and process transactions on the BNB Smart Chain blockchain. So the EVM operates on a set of instructions called OpCodes, as I mentioned, which define the actions that can be performed with the virtual machine. These opcodes are executed when a smart contract is called, allowing the contract to modify the state of the blockchain. And since it's important, I also want to explain stack again. It's a data structure used in the EVM to pass parameters between contracts and to store intermediate results during the contract execution, right? And we also have storage here. It's the storage of a contract is where the contract's persistent data is stored. The storage is updated when the contract's code is executed, allowing the contract to modify the state of the blockchain. So when it comes to gas fees, they are fees paid in BNB to the BNB Smart Chain to process transactions and execute smart contracts. The amount of gas required for a transaction or contract execution is determined by the complexity of the operations being performed. So in this regard, the relationship between these components is that they all work together to process transactions and execute smart contracts in the Ethereum Virtual Machine. Operations are executed to perform necessary actions and they will cause some gas, alright? And the stack is used to pass parameters and store intermediate results. Gas also is being used in this regard as well. And lastly, the storage is updated to reflect changes to the state of the blockchain, and gas fees are paid to compensate the network for processing the transactions and executing the smart contracts. So this has been a very technical lecture, and I understand if you don't get everything here, but to be able to create your smart contracts, you basically don't need to understand all of those things in detail, but it's better if you can search for them and have a thorough understanding on them. So that's gonna do it for this video. I will see you in the next one.